The most important thing about safety requirements is realizing that they must be treated specially. You must identify all the requirements that apply to a system that are safety related. Then you must apply an increased level of engineering rigor according to the Safety Integrity Level, or SIL, for those requirements. It is common to see an overly simplistic approach that makes systems unnecessarily expensive and difficult to implement. That approach starts with a set of all the system requirements. Then, the requirements that are clearly supporting the safety goals are highlighted in this example in red. The problem is, once you do that, another analysis reveals that other requirements support the highlighted requirements, so the supporting requirements are also safety related, so they have to be in red. As a simple example, in a car, you'd expect that applying the main service brakes to stop the vehicle is safety critical. But after the requirements for the main service brakes have been highlighted in red, you'll soon discover that other parts of the system can compromise the operation of the brakes. That means that things like anti-lock braking and vehicle stability control will also have safety critical requirements because they both can interfere with the operation of the braking system. Once you've highlighted those in red, you'll find out that the wheel speed sensors are also safety critical because those are inputs fed into the anti-lock braking system, and so on. The problem is that by the time you've peeled back all the layers of supporting requirements, it is common to find out that most, or perhaps even all, of the requirements in your system have been tagged as red, and they're all safety critical. Even worse, if you have, say, 20 normal requirements and one safety requirement allocated to a module, that whole module has to be safety critical, including all the software to implement the non-safety requirements. That's because once you're inside a module, you cannot guarantee that the normal software will not interfere with a safety function. Thus, even if a modest fraction of the requirements have been annotated as safety critical, if they're spread around the system, you're back to finding out that your entire system ends up being safety critical. Safety critical software is typically difficult and expensive to implement compared to normal software. So if your approach to safety identifies requirements that are smeared throughout your system, what you'll find is the whole thing becomes very difficult, time-consuming, and expensive to build because everything ends up being safety critical. There has to be a better way, and fortunately, there is one.